Let's see how you did on this practice problem. So we had it set up. I guess I should read it first, huh? Oh, it's a big one though. A factory worker pushes a 30-kilogram crate a distance of 4.5 meters along a level floor at a constant velocity. Okay, so the key word in here is constant velocity, meaning the forces add up to zero, the acceleration is zero. So the first thing they want us to do is solve for this force. What force is required to make this happen? So I draw my free body diagram, generate my equations for my x and y direction. I do need the y direction because I will have to solve for that normal force so that I can substitute it into my force of friction. In this case, it is kinetic friction, so we will substitute in. It is not a range like in a static situation. So I have F cosine 30 minus mu times what I found my normal force to be, mg plus F sine 30. I went ahead and just plugged that into solver on my calculator, and I got 99.186. Now in part B, they want you to find the work. So you're just going to multiply the component of the force that is parallel with the displacement times the, whoops, I forgot a negative sign, times the displacement. You're going to do that for both work in, work done by friction. Now there is a little tricky tiger trail here if you didn't want to do all of this work. Once you found that positive 386, you do know constant velocity means there's no change in kinetic energy. So I should have a net work of zero. So if I'm putting in 386 joules, friction better be taking all of that energy out so my kinetic energy doesn't change. So yes, I do get that negative 386. Normal force and gravity don't do any work because their forces are perpendicular to the displacement. Add them all up, I do get that 0 joules if I do the calculations. That means the kinetic energy is not changing, which does coincide with the whole idea of the constant velocity here. There you go.